The average new car costs over $48,000 right now. And if you pick the wrong engine, you could be staring at a $6,000 to $12,000 repair bill before you hit 80,000 miles. GM is already facing a class action lawsuit over exactly that, and we'll get into why. But flip that equation around, and there are engines on the market today that are engineered to run 300,000, 500,000, maybe even 1,000,000 miles without major internal work. The catch is that they are not always in the vehicles you would expect. Using data from iSeeCars, Consumer Reports, J.D. Power, and NHTSA, these are 12 modern engines built to outlast everything else on the road. Number 12. Mazda Skyactiv-G, 2.5-liter naturally aspirated 4-cylinder engine. Starting with one nobody talks about, Mazda's Skyactiv-G 2.5-liter naturally aspirated 4-cylinder has been quietly racking up miles in the CX-5, CX-50, and Mazda 3 for over a decade now. It runs a 13:1 compression ratio with forged internals, and Mazda owners average $426 a year in maintenance costs compared to $652 a year for the industry. CX-5 owners on forums report 150,000 to 175,000 trouble-free miles with nothing beyond oil changes and filters. The one knock is that it is direct injection only, so you will eventually need a carbon cleaning. There is also a technical service bulletin for cracked cylinder heads on some models with the cylinder deactivation option. But if you avoid the deactivation models and stay on top of walnut blasting, this thing will run and run. Not flashy, just quietly competent. And sometimes that is exactly what you want. Number 11. The Honda J35Y 3.5-liter V6. Honda's J-Series 3.5-liter V6 has been around in various forms for over 25 years. The current J35Y version powers the Pilot, Passport, Ridgeline, and Odyssey. iSeeCars ranks the Ridgeline as the second longest-lasting truck on the market. The platform routinely averages 280,000 plus miles. The architecture is proven, the parts are cheap, and Honda dealers know this engine inside and out. But there's a catch, and it is a big one. The variable cylinder management system is a known weakness. When cylinders deactivate, vacuum pulls oil into the combustion chambers, wears out rings, and damages catalytic converters over time. A lot of owners install aftermarket VCM disablers for exactly this reason. With the VCM disabled, this is a 300,000-mile engine. Without that fix, you are gambling, but that is important context most listicles leave out. Number 10. Honda K20C4 2.0-liter turbo. This one earned its spot based on hard evidence. A teardown of a 2019 Accord with the K20C4 2.0-liter turbo at 94,000 miles showed internals that looked almost new. Forged steel crankshaft, heat-forged connecting rods, piston cooling jets. This is the same K-Series DNA that made the Civic Si and Type R engines legendary, detuned for daily driving. It powers the Accord 2.0T, Acura RDX, and TLX. The main concern is carbon buildup from direct injection only, and the turbo does add a potential failure point down the road. But the metallurgy and build quality are clearly a cut above. If Honda had given it dual injection, this would rank higher. As it stands, it's still one of the better engineered turbo 4-cylinders you can buy. Number 9. Toyota A25A FKS 2.5-liter Dynamic Force. This is Toyota's bread-and-butter engine, and it's in everything: Camry, RAV4, Highlander FA, Venza, Lexus ES, Lexus NX. The A25A FKS hits 40% thermal efficiency, which is world-leading for a production engine. It uses D4S dual injection, port and direct combined, which solves the carbon buildup problem. It has chain-driven timing, diamond-like carbon-coated piston rings, and electric variable valve timing on the intake. After 8 years in production, there are no catastrophic failure patterns in the data. That's significant. But the flip side is that 300,000-mile examples do not exist yet because the engine is still relatively young. Toyota's engineering analysis noted that this engine moved away from the simple solutions and archaic designs that made the previous generation 2AR-FE so legendarily tough. So, it's earned cautious optimism, not blind faith. Not yet. But here's what makes the next entry even more interesting. Number 8. Toyota A25 AFXS 2.5-liter hybrid. This is the same engine in its hybrid form, and there is a real argument this could outlast the standard model. Atkinson cycle tuning means the engine runs under less stress. The electric motor handles the hardest acceleration loads, which are when the most wear happens. Regenerative braking extends brake and drivetrain life. The system eliminates the conventional starter motor entirely. iSeeCars ranks the Highlander hybrid third overall for longevity. Consumer Reports data shows Toyota hybrids average 15% fewer problems than their gas-only equivalents. The battery pack is the obvious question mark. Toyota hybrid battery warranty is 10 years or 150,000 miles, and real-world data on Prius packs shows most lasting well beyond 200,000 miles. This might be the future of million-mile passenger cars, and that is not a sentence anyone expected to write about a hybrid. Number 7. The Ford 5.0-liter Coyote V8. The Coyote has earned a massive following, and the fundamentals are solid. It uses a forged steel crank and an aluminum block, and it has been in production since 2011, with continuous refinements. The 2018 and later Generation 3 Coyote added dual injection, which was a huge win for long-term valve health. Earlier direct injection-only models had real carbon buildup issues. But here's where honesty matters. The Coyote uses 4 cam phasers, and those are a documented weak point. The startup rattle on cold mornings is well known in the F-150 community, and phaser replacement costs $2,000 to $3,000. So the core rotating assembly is strong. The Generation 3 dual injection was the right move, but the complexity of 4 cam phasers keeps it from ranking higher. A 300,000-mile Coyote is very achievable. $1 million? The phasers would need to be addressed at least once or twice along the way. Now we're into the heavy-duty diesels, and the competition gets serious. GM's L5P Duramax is a 6.6-liter diesel that has been in the Silverado and Sierra heavy-duty since 2017, making 470 horsepower and 975 pound-feet of torque in current form. GM rates 95% engine survival at 200,000 miles, and real-world examples have crossed 500,000 miles. The L5P was the first Duramax with a factory lift pump, which reduces injection pump stress, and it pairs with the Allison 10-speed automatic transmission, which is arguably the best automatic in any truck. The most common headache is water pump failures from 60,000 to 80,000 miles. Not cheap, but not a design-level catastrophe either. For used buyers in 2026, the 2017 to 2022 L5P is the sweet spot. Fully mature engineering, enough road time to prove itself, and priced below the newest models. But the next 2 diesels have even stronger cases. Number 5. Ford 6.7-liter Powerstroke diesel. Ford's first in-house diesel design, and they overbuilt it on purpose. The block is compacted graphite iron, which is lighter and stronger than traditional cast iron. 6 bolt main caps per cylinder virtually eliminated the head gasket failures that plagued older Powerstrokes. Ford claims a B10 design life of 500,000 miles for the medium-duty 330 horsepower version. That means Ford expects 90% of those engines to need 0 major internal work before 500,000 miles. The 2011 to 2014 models had issues. Ceramic turbo bearings in the problematic CP4 fuel pump caused real headaches. But 2015 and newer resolved both, and that generation is what you want. Fleet operators routinely plan for 300,000 to 500,000 miles. The emission system, not the engine block, is what you will be maintaining. That is true of every modern diesel, and it is the trade-off you accept for this kind of longevity. Number 4. Cummins 6.7-liter turbo diesel inline-six. The Cummins name carries weight for a reason. The older 5.9-liter has over 90 documented million-mile trucks, and the current 6.7 inherits that same inline-six architecture. It uses a cast iron block with special alloy enrichment, a forged steel crankshaft with 7 oversized main bearings, 6 head bolts per cylinder, and gear-driven timing, so there is no belt or chain to replace. The 6.7 makes up to 420 horsepower and 1,075 pound-feet in high output form. Cummins rates it at a B50 life of 350,000 miles, meaning half may need an overhaul by then. Realistic consumer expectations are 300,000 to 500,000 miles with normal maintenance, and 500,000 to 750,000 miles with proactive care. The emission system is the limiting factor, not the iron. Exhaust gas recirculation coolers, diesel particulate filters, and diesel exhaust fluid systems need attention, and they are not cheap. But the engine underneath was designed for agricultural and industrial duty. A pickup truck is easy mode. What keeps the Cummins at number 4 instead of higher is one thing. Ram builds the truck around it, and Ram's electrical systems, interior components, and body quality do not match the engine's durability. The motor will outlive the truck it is bolted to. Number 3. Toyota 2 GR-FKS 3.5-liter V6. Over 20 years of continuous refinement across the 2 GR family and still going. You will find the current 2 GR-FKS in the Camry V6, the Highlander, the Lexus ES 350, and the RX 350. D4S dual injection solves carbon buildup. Chain-driven timing with no belt to snap. Forged steel crank and connecting rods. Aluminum pistons with resin coating and oil cooling jets. Hydraulic lash adjusters mean you never touch the valves. Club Lexus forum members routinely report 300,000 miles or more on these engines, with nothing beyond standard maintenance. The known weak points are water pump failures and ignition coils, both maintenance items, not design flaws. This is the best naturally aspirated gas V6 you can buy for long-term ownership, and the data backs that up. iSeeCars places Toyota and Lexus vehicles in 10 of the top 25 longest-lasting vehicles, and the 2 GR powers a huge chunk of that list. Number 2. GM 6.6-liter L8T gas V8. This is going to confuse people who just heard us talk about GM's lifter problems because this is a completely different engine, and the distinction matters. The 6.6-liter L8T in the Silverado and Sierra heavy-duty trucks uses a cast iron block, forged steel crank, powder metal connecting rods, and push rod simplicity. It makes 401 horsepower on regular 87-octane gas. And the critical detail, no active fuel management, no dynamic fuel management, no cylinder deactivation at all. That system is the single biggest reliability killer in GM's half-ton V8 engines, and the L8T does not have it. Motor Reviewer calls it the most reliable engine in the entire Gen 5 small block family. Fleet operators love it because there is almost nothing to go wrong. The trade-off is fuel economy. You are looking at 8 to 14 miles per gallon depending on load. But if your priority is an engine that will simply refuse to quit, this is GM at its best. Honest, overbuilt, and refreshingly simple. Number 1. The Ford 7.3-liter Godzilla V8. This engine checks every single box for extreme longevity and then goes further. Ford's 7.3-liter Godzilla V8 launched in 2020 in the Super Duty lineup, from the F250 all the way up to the F750 commercial truck. It makes 430 horsepower and 485 pound-feet of torque, naturally aspirated. It uses a cast iron block for thermal stability and wear resistance. It has port fuel injection only, so zero carbon buildup on the valves. The design is pushrod, cam and block, with no cam phasers to fail. It uses a forged steel crankshaft that has been pushed past 1,800 horsepower on the dyno with a supercharger, proving the bottom end has absurd headroom. And there is no turbocharger to cook the oil. A retired Ford director of global engine engineering, Brian Wolf, personally tested these blocks to their limits, and they just would not break. The most commonly reported issue is spark plug wire failures. That is a $10 part. It is still a young engine, introduced in 2020, so we do not have examples with 300,000 miles yet. But every engineering indicator says this thing was designed from the ground up to run forever. Cast iron, port injection, pushrod simplicity, naturally aspirated, forged internals. It is the opposite of everything that is killing modern engines. If any gas engine made today is going to join the million-mile club, the Godzilla is the one.